Is it audible?
Yes, sir. Yeah.
Yeah. Yeah. Good evening, everyone. Good evening, faculties. Yeah, today is the fourth day of our FTP, and today we have Jeremy. On the today's introduction, about Jeremy is going to give by our professor, coordinator of our Think Scholar Publishing, Dr. R. Srinivasan, will introduce about our today's guest. Srinivasan, sir.
Yes, sir. Yes, sir. Is
Sir,
audible?
yes.
Is audible?
Yes, it is audible, sir. Yes, you can give the introduction about our today's guest.
Good evening to all. Today we have Jeremy, sir, tech lead at Product AI with us. Jeremy's journey is through 0 to 1.
The video is not visible, sir.
Videos. Some problem in the video.
Yes, please go ahead. Please go ahead. Please give an introduction about our today's guest, please.
Jeremy's journey is here through 0 to 1 startup story. He joined Product AI as their first intern and went on to architect their entire tech stack. Over just 2 years, he built a generic AI powered omni-channel CRM platform from scratch, integrating real-time calling, AI voice agents, WhatsApp, and web chat into an unified system. He brings a deep expertise in microservice architecture, fine-tuned LLM like Llama 2 and Mistral, and building scalable AI platform. Jeremy will share both the technical and the strategic lessons he learned while taking a product from idea to production ready enterprise solution. Now let's welcome Jeremy, sir. Welcome, sir.
Yes, thank you. Thank you so much, sir. I'm audible now, sir. Everybody can hear me?
Yes, sir.
Yes.
Okay. 1 minute. I'll just screen share. Yes. So let's start the session. Today I'm going to talk about natural language processing and GPT and as well as ChatGPT for teaching support. So these are two different broad topics that we'll be discussing. The first one is a very interesting topic called natural language processing. We'll see what is that, and also we'll also see how it works in a fundamental level. We'll do some hands-on experiments and convert text to embeddings, text to computer understanding languages, and etc. Okay. So how I would like this session to be is we'll mostly like this session to be more interactive. You can stop me whenever you want to ask a question. Just interrupt and ask a question. That would do. I can answer all your questions. And the other thing would be you don't have to worry about taking notes. You can take notes, definitely, of course. But I will share all the recommended materials on all the necessary materials to the coordinator, and he will share it to you as well. Okay. So if you are sincerely taking notes, if you are thinking that you will lose some points on looking into the session, you don't have to worry on that regard. Okay. Okay. Going forward, these are our main three objectives today. One is we'll understand about NLP, and another thing is we will look into the tools that we would be using to support teaching. We'll also be looking into ChatGPT. We'll also be looking into Claude and few other models. I will be explaining what are all of these and how can you use these models to its fullest capability so that you can use it to, you know, aid in teaching and support. And apart from that, we will also be building few chatbots, a very high-level chatbot, not a complex one, because we may not be able to build a complex one in the given amount of time. We will be building small models, small chat applications, which will do Q&A, and you can probably in the future change the code base to, change the file. For example, you can give a book and it will understand the book, learn the book, and further you can ask questions on top of it as well. And use the same model to create question answers from the book also, since it knows the knowledge of the entire book. So these are the three main broad aspects that we'll be covering today. Any questions? No questions, right, on this regard? Okay. So the first thing that we would be covering today is natural language processing. So when you hear the word natural language processing and the NLP, most of you would have heard of NLP, most of you might be teaching NLP and etc. Right? So what is NLP is a question that somebody would I would like somebody to answer from the court. Somebody could answer this question from the uh, participants. What is NLP? What is natural language processing? Anything can be anything is fine. Whatever you think. What is NLP is? I'm audible, right? Hello, sir, am I audible?
Yes, sir. Audible, sir.
Okay, sir, can you tell me what is natural language processing? Any idea about what is it?
Sir, before AI, NLP um, technique has come.
Correct. So that is a right way to think of it, right? So before NLP, before AI, NLP has come, right? You're right based on that regard. But so the thing is, NLP paved the way to create large language models, which are
Like
ChatGPT, Claude, and
like
etc. Yes, go
logic
ahead, sir.
predictions.
Yes, large predictions and finding similarity between words and etc. For that, natural language processing has been entirely useful. Okay, so before we go on to AI, like you said, people started building natural language processing. Natural language processing, you can think it of as a bridge between human readable language and computer understanding language. The language that computer understands and the language that human understands. So NLP acts as a bridge in between. Okay, you got it? Right. Going forward, this is the basic fundamental term of what is natural language processing. Natural language processing is basically teaching computers to understand and work with human language. So let's say I say my name is Jeremy, and the computer should understand Jeremy is a noun. Jeremy is a name, and Jeremy represents a person, um, and etc. Right? I am, and he is Jeremy, and all these things it has to infer from a single sentence. I am Jeremy. Okay, so it is basically teaching computers to understand and work with human knowledge, the way we naturally speak and write. The way we naturally speak and write should also be understandable by computers in order for them to work along with us. For example, nowadays you people might be using ChatGPT. You go to ChatGPT and ask what is the capital of India. It is able to understand this particular guy is asking a question, and he is asking about capital of India, India as a country, and all of this it is able to process in a milliseconds of time and is able to return back saying Delhi is the capital of India. Okay, so that is how the understanding of we will be looking into deeply how this works and how what is capital of India converts to machine readable language as well. Okay, so on a high scale, let's say think of this like this. When you talk to a friend, they automatically understand what you speak. It is not just when I say what is capital of India, immediately the computer understands capital of India is Delhi and gives back. It also understands the context. In ChatGPT, you say, my name is Jeremy, and it says, "Hi, Jeremy, how can I help you today?" And further, you ask a question, "Who am I?" So it will be able to tell you are Jeremy because it knows the entire context of what you have spoken to the LLM or the ChatGPT. So it preserves the context, right? So that all is also a great part of NLP. So that is what is written here. You know how when you talk to a friend, they automatically understand what you mean. Pick up on a context and can respond appropriately. Well, computers don't naturally get languages the human do. They don't naturally understand, they don't by default understand what we speak. So to make a computer understand, we'll have to convert the words into symbols, okay, and numbers, which the computer can process and understand. So this is the way in which the computer will understand. So NLP is a field, like I said already, that tries to bridge this gap, the communication between the humans and the computers. It tries to bridge these two gaps. It is like giving computers a crash course on human communication. It is like how you teach a baby to speak, right? There is a course, there are books, they learn A, B, C, D, and etc. Similarly, the computers will also learn how to understand things by converting the natural language. Now, by natural language, I mean human readable language to a language that the computer understands, which is numbers. Okay. Any doubts still here? Cool. No doubts. Let's move further. So understanding what you're saying, like when you ask Siri, you people might
Faculties,
have yes.
faculties, if you have any doubts, you can ask Dhananjay.
Yes, please ask Dhananjay. Yeah, I'm ready to, more than happy to help you guys. Okay, cool. So, like when you ask Siri a question, it actually knows what you're asking for rather than just hearing random sounds, right? For example, for Siri is a machine. For the people who have iPhone here, they can long press their power button and Siri comes up. You say hi Siri, it replies back to you like a person talking to you. So for Siri, it is not just sound. Whereas for a cat, it might just be a sound because cat is not able to process what you're talking and when what you're implying on. You say hi, cat cannot understand that you're greeting the cat, right? Rather, Siri is able to understand. So how is it able to understand is what we'll be figuring out in depth today. So, for example, understanding that feeling I'm blue. So, feeling I'm blue is an idiom. What are idioms? Idioms are like beating around the bush, and the words such as like which has another meaning in depth, but they call it like feeling. I'm feeling blue probably means you are sad, but not that you're turned into a color, right? So, Siri is also able to figure out idioms and also make sense of what I am blue is, right? I let me press the power button and say, I'm feeling blue, Siri, tell me a joke. It will not immediately panic and say, why are you turning blue? Did you eat something bad or not like that? It will tell me a joke because it understands I am feeling blue is idiom rather not a word. Okay, not a sentence, probably. Yes. So to respond appropriately, chatbots will convert conversations or translation apps that convert your English to Spanish. All this is fine. Extract it. It can also extract useful information such as reading to thousands of customers' reviews, automatically figuring out whether people generally like or dislike a product. So this is also one of the major use case of NLP where people apply NLP and they ask the large language models or the NLP model to completely read through reviews of a product and do classification on top of it, which can be intent classification, sentiment classification, um, and lot more. Okay, so intent classification by sentiment classification in the sense I mean, is it a positive feedback? Is it a negative feedback? What is the user wanting? What is the company lacking? Everything can be identified by using NLP and its applications. Okay, cool. Now, in the recent trends, there is something called word embeddings. Has anybody in the faculties come across the word embeddings? Let's try this to let's try to make this session as much as interactive as possible. It can be either no or yes. Anybody can tell me, no problem.
Sir,
Faculties have
like
worked on.
substitution method.
Yes, tell me, sir.
Here it was like in substitution method.
Substitution method, where can you kindly explain more, sir?
In like cryptography, we can substitute one letter instead of another letter.
No, sir. This is not related to cryptography. That substitution is different, sir.
Okay, sir. Okay.
This is with respect to AI and NLP. Anybody doing projects on deep learning, uh, uh, fine-tuning LLMs will be able to understand. Cool, let's move further. So, like I said before, um, in order for a computer to understand what we speak, it has to convert the spoken words into numbers, bare numbers, because the the lowest language that a computer can understand is binary, which is ones and zeros, right? So, in order to convert our spoken language into numbers, we need something called embeddings. Okay, so what embeddings will do? Embeddings will take the word that we have, and for each word or in each sentence, it will give you the equivalent numbers. So this is a clever trick when computers convert words to numbers, and these numbers are called vectors. Okay, so vectors. So let's say, um, mm, uh, how do I? Okay, cool. Let's say it's called vectors. For now, let it be vectors. Later on, I'll explain you what are vectors and what is the difference between embeddings and vectors. Okay, so this is a clever trick when computer converts words. Words in the sense human readable words. It can be I am Jeremy, I am in Bangalore, I am in Mumbai, etc. Okay, into numbers called vectors that capture meaning. Words with similar meaning get similar numbers. So the word king and the word queen would be close together in this number space. King minus man plus woman mathematically gets you queen. So all this is inferred from vectors, which are nothing but a word, a human readable word converted to a computer understanding language, which are numbers. Okay. So again, applications on NLP, this we have already seen. It helps you understand what you're saying, like you're asking Siri a question, it actually knows what you're asking for rather than hearing random sounds, figuring out all this is done, repeated. Yes. So in use case of embeddings. So now we are going deep into embeddings. We started from NLP. We started to understand what is an NLP, how human readable language is to be fed to computers. Now we are going through the mechanism of converting human readable language to numbers so that we can feed to computers so that they understand what we are talking. Okay. So the king, at the end of the day, the word king will become this. The king will be represented in terms of numbers like this. So this is what we call a vector of king. And queen will also be represented in this manner. Okay. So if you could see, there are few similarities in this. So 0.8 is minus 0.8 here, whereas it is 0.7, 0.2 is very nearby, 0.3, and 5 is 4, 0.2 is 1, and etc. So which means the difference between these two numbers are very close. Like 0.1 decimal is the difference, right? So notice how similar the numbers are. Of course, they are similar. Meanwhile, pizza, a word, if you try to convert pizza into an embedding and check its numbers, it will be entirely different. That is because the pizza and king, the word king, has very less uh, commonalities with them. Okay, so that is why they have uh, the embeddings are completely different. By commonalities, I mean similarities. They have very less similarities with them. So this changed everything because now, since the launch of embeddings and the fast-moving pace of natural language processing, similarities have become measurable. Now there is a analysis, or you can quantitatively say king and queen are this much close. Since you're able to represent in terms of a number, you can find the difference and say, this is the similarity value of king and queen. Okay. So computers can mathematically calculate happy and joyful are more similar than happy and car. So context matters, advanced embeddings like BERT or GPT. So there are several ways in which you can convert the words to numbers like you can see on the screen here. This is the word and this is the number. there are so many methods by which you can convert this to this number. One of that method is BERT and the other is GPT. And there are few more, and there are open source models that you can use to convert as well. Okay. Create numbers from representations of the same word depending on the context. So bank in river bank gets a different number than bank in the money bank, right? So this is how the embedding model understands that these two are the same word. But when you add another word on top of bank, the embedding number completely changes, which means it gets an entirely different meaning. Okay. All this we will see in practice as well. So relationships are also captured. The most famous, the famous examples like king plus man plus woman is equal to queen work because the embeddings encode gender and royalty between relationship between number patterns. So transfer learning works. You can train embeddings on massive amount of text, then use them to ask specific questions, find the closest word, and etc. Okay. So any questions till embeddings, faculties? If anybody didn't understand embeddings, I'm happy to explain it again as well. Moving forward, now since we know what is an embedding is nothing but a representation of a word, right? Now, where do we store these embeddings? Since king is converted to this number of words, this is a very big array of numbers. Array of number in the sense I mean collection of numbers, right? It will be 1500 collection of numbers per word. So single word, when you convert to an embedding or a vector, it will become 1500 numbers. Okay, so which is a big number, big value to store and process. So in order to do that, in order to work on embeddings, you need something called vector databases. Our traditional Postgres database, our traditional SQL database, our traditional NoSQL MongoDB, um, uh, whatever traditional database that we use will not work for embeddings. Okay, because their entire architecture changes, you will just have to store large numbers. Okay, so that is why there are new databases that are launched in order to work with vectors and work with AIs. Those are Pinecone, ChromaDB, Quadrant, PG vector stands for nothing but PostgreSQL vector. So if you're already using a Postgres solution and building a project, and you want to add AI solutions and vector applications on top of it, you can use Postgres vector. And there is another DB called VV8, and FIA stands for Facebook AI fast, I think fast AI solution, something like that. This is developed by Facebook. And the most common used vector DB is Pinecone, and most reliable and fast vector DB is Quadrant here. Okay, just take a note of it so that in case in future, if you are working on AI and vectors, this vector DB would come into play and would be more helpful for your use case. Now, how will you convert a text to that particular uh, uh, numbers, right? And put it inside database. The conversion process will require a model. Okay, these models are there are several open source models and there are several um, paid models as well. OpenAI, have you heard? You must have heard of OpenAI, the founder of ChatGPT. They also provide text embedding V3, which is a popular model which can be used to convert text to uh, embeddings. Okay, Google also provides a model called embedding 001, which is also a very popular model and can be used to convert text to numbers, which is embeddings. Again, similarly, Gina V2 is there. If you need a whole lot of context on where to figure out a lot of embedding models, you can check out this link. I will be sharing this link as well. So here a list of all providers and their embedding model is also available. So all embedding models, you can find the various Databricks embedding models, Google Gemini, Google Vertex. So there are so many embedding models. People have built so many embedding models which can be used to convert word to numbers, which are further understandable by computers. Okay, cool, fine. Okay, so this is one thing. Now let's come to the hands-on part of how to convert words to embeddings. I am just opening a Google Colab and you should be able to see this, right? So what I'm doing right now is this is import Google from GenAI, which will just import my required packages. I'll just move this to this thing. And I'm also asking for a API key. Okay. Because we need API keys to convert. I'm using Google Gemini 001, which we just saw in the top embedding models. I'm using this to convert text to numbers. Okay. So when I do this, when I run this, it'll import the necessary files required for it to run. It's just running. Now it'll ask me for an API key. Yes, so it is asking me for an API key, which I will have to input. I'll just take an API key, which I have already. An API key. And I'm just using the API key. Now, API key has got loaded in this. Now, what I'm doing, I am again bringing up the client, which is all this is publicly available. You can just search for Google embedding, and you can on the first you can see Google AI for developers. You can go inside that, and they will give you code examples. The same code examples. I'm just following the same code examples, nothing else. So here is where we give content. I'm saying, hi, I am Jeremy. You are able to see, right? I'm just zooming it up. Okay. I am Jeremy. I'm just trying to run this. Now, if you see here very close, I'll print the embeddings. So it is nothing but a array of numbers. Can you see this, faculties? So it is a very big number, if you could see, right? Now, let's see how big it is. It is an array of numbers. So instead of just printing, let's create a new variable called embeds. I'm assigning to empty array and print embeddings. Instead of just printing it, let's print embedding.value to get the values, because values are equal to, right? So we need the values. So I'm just taking the values and I'm assigning this entire thing to embeds. Now, when I print embeds, I'm also printing the length of the embedding. Okay. So this is the length. And I'm just printing the length of embeds. So if I run this again now, you can see this is the embedding number, and there are 3072 numbers in it, which are decimal points, which can be like positive or negative and etc. Right? So if you just check on this, right, it is just hi, I'm Jeremy, which is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Probably how many characters is it? We can again run this. Um, Yep, if we run this, a 14 character sentence, which is hi, I'm Jeremy, is converted to 3072 numbers, which further have a lot of characters, of course. And this is how the AI or the computer understands the word or the sentence, hi, I'm Jeremy. Now you can say these are just bare numbers, right? How do you know that computer is understanding or not? So that is when we do cosine similarity. So there are so many types of similarities, which I don't want to get deeply into, but similarities are nothing but like how we saw joyfulness and happiness. These two are similar. When I say I am Jeremy and I say who is Jeremy, these two sentences are similar because it has the same context of Jeremy, right? So similarly, we have to figure out how similar things are in a sentence in order to understand how it is, right? So now let's do another uh, piece of code where we will again pass the API key to here, and let's just run this. So what we are doing here is we are figuring out what is the similarity between these three sentences. So in order to do that, first what we are doing is we are converting each sentences into numbers like how we have done before. Okay. After we do that, that is the embed content. After we do that, we are creating a cosine similarity. Cosine similarity is nothing but you find the similarity between the words using the numbers. Then further, we just print it here. Not a big deal, right? So the similarity between what is the meaning of life and what is the purpose of existence is 0.9. And the similarity between what is the meaning of life and how do I bake a cake is 0.7. And what is the problem? Oh, it's very less. So what is the purpose of existence and what is the meaning of life are definitely similar, because if you could, as a human being, we can understand and we can feel these two are similar, right? Because it is purpose of existence and what is the meaning of life. Both are just the same, both ask the same fundamental question, but just return it in a different manner. Okay, so that is how we are able to figure out how two sentences are kind of the same, right? We can do another exercise as well. So let's say chemistry is very tough, and I can say programming is very easy, and I can say civil services. Okay, now let me add another text in this saying, what is the toughest language? Now let us run the same program. Now if you see, chemistry is, there is a problem. Oh, one second. Yeah, since it is said, it was saying language, it was confusing with programming. I can ask subject. Now this would be better. Yes. Yeah. So the similarity between, no, what happened? There is a comma missing. Yes. Yeah. So the similarity between what is the toughest subject and chemistry is very tough is the highest. So now you people can, or you can understand how this works, right? The computer is able to understand when I say what is the toughest subject, it knows that chemistry is tough. So this is how when you talk to an LLM, right, it is able to understand because it is fine-tuned and pre-trained on all of these matters. Millions and billions of informations are fed. Now we are just feeding in four information. With these four information, we are asking question, and whatever it knows, right? What is the toughest subject? It knows chemistry is very tough. So it is coming up with that answer. And the similarity matches on 8.7. This is the score. So when coming back to our presentation, when I said this changed everything, because similarity has now become measurable. So now that is exactly what we are doing. We are measuring the similarities between sentences. You could see with respect to a value. So this and this is 0. This value is from 0 to 1. So what is the toughest subject? And chemistry is very tough. Is 0.8. You can say 87% close. Okay. So that is how this works. Any questions still here, faculties? Any questions about embedding models, how it works, and etc. Any doubts? Am I going very fast? Can ask any question. No issues. Okay. So next one would be how to prompt. Now that we have learned how to convert a sentence to a machine readable format, now we have to. There are a specific way in order to talk to LLMs. Now, you people might be using ChatGPT, so you can just log into ChatGPT and you can be like, just say, hi, I want notes about C++ basics, and it will give you the notes, right? But when it comes to a very niche task or a particular task where you want to control the LLM's thinking and where you want to, analyze a feedback and etc., you need to know the art of prompting, right? This is the prompt that I've given now, which is a very basic prompt. This will not work in a production level use case. This will not work in AI firms and startups. Okay. So in order to do that, I will teach you how to write a production scale prompt. So let me just screen share. Yes. So in order to prompt, you'll have to understand the language of Markdown. So Markdown, you can create a Markdown file very easily. You can just open any text editor, create a new file, and just save it as um, demo.md. So MD stands for the extension of the file Markdown. Okay, once you save it, you can start using it. I just created a wrong name. Yes, so this is the Markdown file. So you can use hashtag as h1, like heading header 1, two hashtags as header 2, and so on and so forth. There are so many syntaxes that you can use. So I will just briefly tell you what are all of them. So this is a Markdown cheat sheet that you can follow. So if you see here, in order to create headings, you will have to do this. These are our headings. And in order for you to in order for you to do, 1 second, sorry guys. Yeah, it's bold text. You will have to do bold text like this. Yeah, this represents bold text, and so on and so forth, right? This is block quote, and this is like unordered list. When you want to do a list, you do this. So these are few examples on how you can learn Markdown. It's very simple. So it is like when you write something, when you write a para, you will always write a heading. Instead of just writing a heading, you write like this: Intro to Gen AI, and you start a para inside this. You say this is the intro of, and so on. So you start typing like this, right? So why I'm coming to Markdown right now is LLMs and large language models like ChatGPT, Claude, Gemini are fine-tuned on top of Markdowns. So when you write a prompt, you'll have to write using Markdowns. So let's try it out. So I'm saying you are a feedback analyzer. You will uh, you will have to analyze the feedback and come up with an output. Now, after giving this, you will have to write it. Actually, this is an instruction, right? So you'll have to put it in a instruction, and you'll have to give it an input. Input would be what? Input would be the feedback that we'll be giving it later, not now. And there should be an output format, right? So, and in output format, you'll be asking um, score of the feedback and score CO, the feedback. And the second thing, sorry, I just type this and let analyze the feedback and come back. Yes. Input and the score of the feedback. And further, you will have to you should always ask for reasoning. Reasoning is nothing but what the LLM thinks and why it thinks that this score. Reason for your score. And finally, sentiment, which is positive or negative. Positive or negative. Okay. So if you see, this is a production scale prompt, not a very good production scale prompt, but something better than this is a basic syntax that you should follow when you're prompting. So you should give an instruction. Instruction can be in points. Use all the elements that we have seen in the markdown. Use all of them, and you give an input, which will be your problems input and your output. In what way you want the output to be. So I'm just giving a feedback right now. I hate this product. It worked for 10 days, but didn't work again. But it worked good for the initial 10 days. Okay. And score of the feedback, we just say just a score, right? We have to give it a range. So I'm just telling it 0 to 10 so that it understands and gives us a score. Now, when you do enter, rather than it saying so much jargon, writing paras and paras for you to read through, it will just give you a score, reasoning, and a sentiment. Yes, that's all the output is. Now, in production scale, in companies in IT and AI companies, we just take it and parse it to get the score and the uh, reasoning and negative. So, if you see the reasoning, strong negative language, hit, and reliably failure after 10 days. Brief initial satisfaction does not offset the product making quality quickly. So it is able to give you a very precise and a concise answer, right? So this is the art of prompting, and this is something that you will follow all over wherever you go and prompt in any language, large language models. Any questions with respect to how to prompt? So it is there should be an instruction, input, decide on the output format, and pass the output. These two you can skip only if you need. If you do coding, you will do the last two. Right. Okay. Cool. So I have also attached, since we have very less time, I've also attached a translation prompt. So this is how you, in case we want to do translations, you have to translate to another language and etc. This is a translation prompt for Hindi. You can refer it and try it out. This will give you like 10x more translated, better translation than you just say, translate this word, right? Rather than that, this will give you fantastic output and you will get a good quality from LLMs. Okay. And again, these are models by use case. Now that we have briefly went through about text models, how they understand what you speak, and also how to prompt them, we will see 2 to 3 examples on how to work with image models and video models. Video models are very expensive as of now. The pricing would reduce going forward, but initially we will check with image models. So let's say you faculties would need to create some images that support your PPT or anything like that. But those images are not available in the website or anyway. You have something in your mind. You want to write it. You wanted to bring it as an image. You can use AI generated images. I would recommend you to do it in 2 ways. One is ChatGPT's image gen. You just type it here to create an image, and the other thing is Google's Google Google AI Studio, AI Studio, and the third one is FAL. So if you go to fal.ai, you can find a lot of models that are ready to use here. FAL is paid, whereas these two are not paid. So you can use them, but they have a limit per day. Image generation limit is there. Okay. So here you can say, I need a NLP poster for NLP poster for the session I am talking about. And the same prompt can go here. You'll have, yeah, you have to do this. And this is just going forward. We'll have to wait. Yes. Is designing the poster. So whatever it is, right? See, it has come out well. Now, if I want to give my picture here and ask it to put my picture there, it can do that as well, right? It can do anything. So you will just have to upload the picture of myself, which will be here somewhere. Let's use this image for the speaker. I'm attaching the links for all this. You can also try it out. It's pretty cool. So just skipping the thinking process, it's taking a lot of time. So bit more. It's asking for the session theme, title, and etc. Blah blah blah. Once you give that, it will create something cool here as well in ChatGPT. And if you see now, what it had done is it had put my picture in the place of the speaker, and it has created the poster. Okay, so this is a very brief overview of how you can work with image generation models. Okay. So I've also added cost. We can go through on cost per tokens and etc. This is the creating creative materials. You can create it via the image stuff that I showed you right now. Okay, now the last topic that we would like to I would like to address is about RAGs. Have anybody came across the word RAG? This is very hot in the current AI domain right now. A lot of people are doing research, and so many things are happening in the field of AI with respect to RAG. Has anybody come across what is a RAG? Okay, no problem. So RAG is called RAG is a retrieval augmented generation. It is a process by which you can do question answer on top of a PDF or any document that you have. Okay. So the idea on which how it works is something that we have learned right now. Okay. So you ask a question, it goes to an embedding model, like how we've sent to Google's Gemini embedding model. It converts itself to a vector, like how we converted our text to numbers. You do the same process of converting to a vector. Then we do similarity search on all the text that is there on the book. Let's say I want to do question answer. I have a book with me. I upload the book and I am saying what is the title of the book. Okay. So the title of the book is would be there on the book, right? So this word, the question that I am asking right now, and the book's word will be taken to a similarity search process, and the closest match will be put forward, and that will be passed to an LLM, which will give you an output. So this is the main architecture of how it works. So everything that you see on the screen right now, the RAG that is happening, is working primarily based on the embedding model, which is primarily working on the natural language processing's fundamentals. Okay. Any questions here? Any questions on this architecture? We'll be moving on to a hands-on experience on. We just have 5 minutes more, I guess. Oh, we are closely done. I'll just show you an hands-on experience on how to create the bot. I mean, not how to create a bot, how it basically works. Okay, right. I just need a PDF. I'm just taking a PDF. Yeah, account summary transaction. What is this? Cool. This is a account summary transaction of myself using of my bank account. So I want to do question answer on top of it. You guys can add whatever PDF that you like, which is not a problem. Okay. I go here, document serializer. Yes. Yeah. I'm just changing this to the path of my document. This can be done for any books, anything that you guys could, any books as well, right? No problem on that part. Mm, just a second. Second. Okay. It just looks like some dependency issues. Give me a minute. Check what is the issue. There might be some. Okay, maybe this. Yeah, this might be the problem, most probably. Oh, let us run this again and try. Yes. Okay. Now what we did is we took a file which is nothing but I will show you which file is that, which is this file. It is just my account statement. It has savings account, Mr. Jeremy Ashwath, my place, all the money transactions, all that I made. Okay. So we used that and we created something. We went through each and every pages and we had created something called serialized PDF.txt. Now, if you see by running this program does nothing but it goes through the entire PDF and runs through it and breaks it by page by page. Now, if you see in this document, just a text document, we converted a PDF to text. And this text has page one, total number of characters and words, and it has the information in that page, the second page, and things like that, right? It has all of this with respect, it has broken down into a page, and from a page, we have characters and content in it. Okay. Now, what we do, since we have it in this way, now it will be very easy for an LLM like Gemini or ChatGPT to understand what is happening and figure out and tell you things and how to work on it. Okay. So now what I'm doing is I'm calling main.py. So this code I will share also. So once we do this, it will get loaded. Probably it will ask for my API key, which I don't have. Let me set that up as well. 1 second. Yes. Should. Yeah. So now it's asking for me, it's asking me to ask a question, right? So what kind of question? Let's say, to whom does this account statement belong to? It's a generic question that we are asking here right now. Okay. And it will think, it will read the document or the serialized thingy that we did. And now it is saying in page number 1, we have the answer. The account statement belongs to Mr. Jeremy Asirwaad. The name is Mr. Jeremy Asirwaad, clearly mentioned on top of the first page, which is the standard placement from the data source. Okay. So that is how it works. Now you can ask another complex question as well, like how much transfers were made on how many transfer of funds were made on the particular date. I give it the date. Now it will go through and it will understand and figure out and tell me the transactions that were made on this particular date. Yes, two fund transactions made. One was a credit of 1 lakh and another was a debit of 30,000. Page number 1. It is on the page number 1. Yes, which is correct. This is the page number 1. And it's telling me the number 1 shows two separate entries dated, both received a transfer. I can also ask a few other questions on the last of the page as well. I could see like we refer to RB notification, Susan nominee, West Bengal. Where all does the what is this? HDFC state list and GHT details. Can you tell me HSBC, right? Yeah, HSBC state date list and GSTIN details. Now again, it will go through the documents and figure out this where this is located.
Jeremy,
Yes,
yes, you can just show them 1 or 2 examples and we can move to the next.
yes, this is done. Then we can, yeah, that's it then. That is on the hands-on of creating Q&A button track. So we have covered all 3 topics for today. Any questions you can ask me right now.
The faculties, if you have any questions, you can shoot on. I will give you 2 minutes time so the faculties can ask any questions. And after that, we can conclude the session. The faculties don't have any doubts. Alexander sir, Paradi, Vinisha, Brinda, Vijay Kumar sir, Nalasivam sir, Jayendran sir, Jaiprada madam, Redeshini. Don't have any doubts. Can I conclude the session? I think at least one question. I'm expecting at least one question from your faculties. Anyone? No one. Fine. I'm going to conclude the session. Okay, fine. Jeremy delivered an insightful session today, offering deep perspectives on prompting. It was an engaging live session that spotlighted on key aspects of the topic. So thank you, Jeremy,
Thank you, sir.
for sharing your valuable time today with us.
Thank you so much for having me,
Your
sir.
expertise and contributions have truly enriched today's session.
Thank you.
So thank you, everyone. So thank you, Jeremy, once again.
Yes,
Thank
sir.
you,
Yes,
faculty.
thank you, sir.
Yeah, we are going to wind up the session. Thank you. Thank you so much.
Thank you, sir. Take care.
Srinivasan, sir? Yeah. First, can switch off.